for pre-calculus. So we're going to start off with some easier items, more of a review with a little bit of a twist, a pre-calc twist to them. So we're first going to start by reminding ourselves about the Pythagorean Theorem, which states that the sum of the squares of the legs of a right triangle will equal the square of the hypotenuse of the triangle. In graphical form, the triangle is shown on the left, and I give the photo credit to if you want to read more about it. That is a hyperlink that is used within the notes, but a squared plus b squared is c squared. So let's use this to find the distance between the points -3, 2 and 2, 5. So it looks like we're going to be utilizing these 2 points. And we're going to use the Pythagorean theorem to identify the distance rather than using the distance formula, which we will cover next. I can count, since they're nice even values, I can count that the side of the left side is 3 units and that the side along the top is 5 units. Therefore, by utilizing the Pythagorean theorem, I can find the length of my hypotenuse. So my legs squared, a squared plus b squared is c squared. In this instance, we have 3 squared plus 5 squared is still c squared. We need to identify the hypotenuse length. Therefore, 9 plus 25 is c squared. 34 is c squared. Therefore, the square root of 34 in its exact form is the length of c. Now, how can we utilize the distance formula if we don't always have nice, neat values where we can easily count? Sometimes the distance formula can be useful for us. So I'm going to use the points 1, 6, and 3, 5. All we need are 2 points to utilize the distance formula. Notice that we're taking the difference of our x values and then squaring them, and the difference of our y values and then squaring them. Keep in mind that it doesn't matter if you do the first or the second point first, as long as you're consistent throughout. So I'm going to take the second x minus the first x, square it, then add to that the second y value minus the first y value and square it. This then provides us with 3, the second x value minus the first x value squared, plus the second y value minus the first y value and square it, is the square root of 2 squared plus -1 squared, or the square root of 5, since 4 plus 1 is 5. Well, that's great and dandy. Either option would certainly work, depending upon your preference. On the next page, we're going to talk a little bit about the equation of a circle. When we are centered at a point HK and we are given a radius, which is r squared. So the equation is x minus h squared plus y minus k squared is the radius squared. In our example, find the equation for a circle centered at the point -3, 2 with a radius of 4. So I already know my h value, I know my k value, and I know my r value. Super easy then to put this into our equation. Keep in mind that we're subtracting. So I'm going to be taking x minus a -3 squared plus y minus our y value squared is 4 squared, and then cleaning it up just a little bit because I know that double negative turns into x plus 3 squared plus y minus 2 squared is 16. Our next example, write an equation for the circle which is graphed. I've got the little picture here. We are centered at 0, 0. That's awesome. So our center is at 0, 0. That's nice for us. And I do see that my endpoints here, I've got 3, 0, 0, 3, etc. So I know the distance from the center to one of my vertices is in fact 3 units. So my radius is 3. Therefore, my equation is going to strictly be x squared plus y squared is 3 squared, or x squared, since I'm not adding or subtracting, I have x minus 0 squared, which is just simply x squared, plus y squared is 9. On slide 3 here, we are going to find the points on a circle of radius 5 centered at the origin with an x value of 3. So now we're getting a little bit more difficult here. Find the points on a circle of radius 5 centered at the origin with an x value of 3. So potentially we might have 2 y values that we might be looking for here. I know that if I'm at the origin, my center is at 0, 0. I know that my x value is 3, but I don't know what my y value is. I also know that my radius is 5. And I also know that the generic form we can utilize since I have the center at 0, 0, and I know my radius. I know my equation must be x squared plus y squared is 25, since 5 squared is 25. I also know that my x value is 3. If I substitute my x value for 3m, I'll have 3 squared, or 9, plus y squared is 25, which would now allow me to solve for y. I can subtract 9 from both sides, therefore y is 16, and when I take the square root, I know that the square root of 16 is plus or minus 4. Therefore, I must have the point 3, 4, and 3, negative 4 on my circle. So those are the 2 values. Find the x-intercepts. Find the x-intercepts of a circle that has a radius of 6 and it's centered at the point 2, 4. We already are given that, so we already know our h and our k value. We're looking for x-intercepts. What does it mean to be the x-intercept? Well, recall that an x-intercept is where our, just kind of randomly putting 2 points here, our x-intercept means that we are on the x-axis. If we are on the x-axis, that means our y value is always 0 with the x-intercepts. And therefore, since we have an equation, we can easily substitute just in a different manner. Our equation then, because we know our h value, we have x minus 2 squared plus y minus 4 squared is our radius squared of 36. Well, again, I know what my y value is. I need to know what my x values potentially could be. So I'm going to substitute in for y, my 0, and begin solving. I'll have x minus 2 squared plus 16, since I'll have 0 minus 4 and negative 4 squared is 16, is 36. X minus 2 squared is 20. Since 36 minus 16 is 20, I can undo my square by taking the square root of both sides. Therefore, I have x minus 2 is equal to the square root of 20. I know I could simplify the square root of 20 since 4 times 5 is 20, and I can take the square root of 4. Therefore, it would be 2 plus or minus, I should say, plus or minus 2 square roots 5 to reduce that radical. And then finally adding 2 to both sides. Therefore, x has to be 2 plus or minus 2 square roots of 5. So we really have 2 x-intercepts here, right? We have the x-intercept where we have 2 plus 2 square roots of 5, 0, and the second one, 2 minus 2 square roots 5, 0. So there are 2 x-intercepts in this instance. So notice that I kept these in exact form. When you're using MyOpenMath, make sure that you are putting your answers in exact form, not in decimal form, unless it specifically states to round to a certain decimal. Our next example In a town, Main Street runs east to west and Meridian Road runs north and south. A pizza store is located on Meridian, 2 miles south of the intersection of Main and Meridian. If the store advertises that it delivers within a 3-mile radius, how much of Main Street do they deliver to? So I have a start of a picture here. Let's assume that this here is Main Street, since it is running east and west, so left and right. Meridian Road runs north and south, so we'll say that the y-axis is Meridian Road. And since a pizza store is located on Meridian, 2 miles south of the intersection of Main and Meridian. So we are 2 miles south, so we can assume that the pizza store is at the origin, which is helpful when we're writing an equation. Further, we know that it is a radius of 3 miles. So if a store advertises that delivers within a 3-mile radius, how much of Main Street do they deliver to? So we're looking for, first of all, where are the intersections here? What are the intersections of these two lines? And then further, outside of that, what is the distance here that we're looking for? So that's kind of what we're going to do. I know that we have the equation y equals 2. That is the equation of Main Street since it's a horizontal line. I also know that within my circle, the equation of this particular circle, when we are centered at 0, 0 with a radius of 3, the equation of the circle is x squared plus y squared is 9. We're interested in where do these two intersect each other. Where do these two intersect? Because that's where they're equal to one another. That's where these red dots are equal to one another. Well, since I know y is already equal to 2, we could easily substitute this in and find those x values. I do know for a fact that this point is going to be something positive 2 and over here is going to be something positive 2. But what is that x value that's listed there? We can't assume that it's exactly at 2 because it's really not. So we'll substitute 2 and we'll have x squared plus 4 is 9. X squared is 5. So therefore x has to be plus or minus the square root of 5. So, and please note, friends, that if I were to tell somebody that the distance was about square roots 5 miles from something, they would probably look at us a little silly. So we do have to realistically say that this is plus or minus about 2.236 miles east of Main. And it's also 2.236 miles west of Main. Because we don't list distances in negative values. So from here, east of Main is 2.236 miles, and then west of Main is also 2.236 miles. Therefore, we can find the total distance by adding 2.236, the one that's east of Main, plus 2.236 west of Main. So the distance approximately is 4.472 miles long. Along those same lines, let's head to slide 5. Here again, I'm using Desmos, and we frequently use that in college algebra, so it's another way for us to verify what we're visually seeing is what we're algebraically determining. It's asking us to determine where our line y is 4x, where does it intersect the circle x minus 2 squared plus y squared is 16. So if we notice here on my graph, I have y equals 4x, so we also know y is fancy wording for f of x. I know that this is a nice straight linear line, so it does represent the red line. And the blue line, of course, is our circle. So I want to know where these are equal. Since I know y is equal to 4x, we can substitute that in here and then solve easily for x. So what are the x values that are approximately equivalent? So let's start off by saying, well, I know that x minus 2 squared is the same as x minus 2 times itself. And then I also have another 4x squared, since y is equal to 4x, equal to 16. So we've got some expanding that we need to work on. If I distribute my x minus 2, we have x squared minus 2x plus 4 plus 16x squared equals 16. Let's combine like terms. I have 17x squareds minus 4x minus 12. Set it equal to 0 by subtracting 16 from both sides. Obviously, as we look at the answer provided using Desmos, these are not going to be easily factorable, so we're going to need to use the quadratic formula. So x is going to be equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c, which is negative 12, over 2 times a. I'll let you simplify those a little bit, but we should get 4 plus or minus the square root of 832 all over 34. These are not nice numbers. We're going to definitely need to have some decimals here in order. Since this is just x, we still need to find out what our y values are, because we need to find the two locations. We need an x value and a y value. These are then approximately 0.966 and the -7 or 0.731, which certainly match when we plug into our calculator the two x values. Therefore, to find our y values, we'll need to substitute them in. I'm going to use the f of x since it's much easier. So what is f of 966 thousandths? And we should get approximately 3.864 thousandths. Again, matching what we visually see in Desmos. And f of negative 731 thousandths, so 4 times that value, gives us approximately negative 923 thousandths, which also matches here. Okay. Now, depending upon the linear line, it may only touch the circle once, and it may touch it twice, or if it's not even near the circle, there may be no solution. So just be aware that they could have one single point, maybe it only touches the circle one time, or maybe your linear line's over here, in which case there would be no solution since they don't touch each other. So keep in mind, you could have one solution, you could have two solutions, or no solution. Just be aware that that could be a possibility when going through your assignment. And the last example, very something similar, where we've got a linear line and we have a circle, but we're not given those equations. So we're going to need to find what those equations are before we can use our technology tool in order to help us. So what do we know? We know that a small radio transmitter broadcasts in a 50-mile radius. So let's start there. If it's in a 50-mile radius, I know R is 50, and we know that if we can place this anywhere we desire to do so. So perhaps I might want to put my center of my radio transmitter in the origin. That would mean that this point here would be 50, 0, 0, 50, etc. around. The equation then of this particular transmitter is x squared plus y squared is 50 squared, right? If you drive along a straight line from a city that is 60 miles north of the transmitter, so we're starting at 60 miles north of the transmitter, so now we're at 0, 60 here, this is where we're starting. And we are traveling to a city that is 70 miles east of the transmitter, so 70, 0, that's where we're going to. Something like this. How much of the drive, so from here to here, how much of this drive, we want to know what this distance is, will we pick up the signal from the transmitter? Well, I do know that I have a linear line, but we're not given any nice information outside of the y-axis or the y-intercept, but I do know my slope. So if I look at here, y is mx plus b. I know that my slope would be falling from here to here. I'd be falling 60 units and running 70 units, which reduces to negative 6/7. I also know that our b value is positive 60 because that's our y-intercept. So the equation for this graph is y equals negative 6/7 x plus 60. So I want to know, where do these two intersect one another? Also, I have the two equations here because, as we know, the mathematics might get a little convoluted and they're not going to always be nice, but that's where those are coming from so that I could get the picture on the right hand side. Therefore, I'll have x squared, x squared plus, well, I know y squared, my y value is here, so negative 6/7 x plus 60 times itself, since there's two of them, still equals 50 squared. That's a whole lot. I'll let you do the solving by distribution and simplifying. We'll end up getting two different points to solve for. One will be a nice neat number and one will not. But we also see that the solutions are here and here. So you could algebraically solve or use our graphing calculator, but we're actually looking for the distance, right? Because it's asking how far will we pick up the signal. So what is the distance from this point to this point? And we found those 2 points by finding where they intersected. So the 2 points after we solved, we ended up with the 2 points 1448 and a decimal. And 21, we'll just round them to 2 decimal places. So therefore we can use the distance formula, because that's ultimately what we're looking for. The purpose isn't for you to, I mean, yes, you have to solve algebraically, but the idea here was that we needed all of those pieces in order to actually utilize that distance formula. So I can take my difference of my x values, so 45.29 minus 14 squared plus 21.18 minus 48 squared, and taking the square root of all of that, we will pick up the radio transmission for approximately 41.21 miles. So it made sense to utilize decimals here based on what we're actually trying to find. So again, please make sure that you're being careful with the results within MyOpenMath.